Okay, welcome. What we're going to try to do now is show you how to use the EMU in a very simplistic manner. We will take a reference file, open it up with Audacity, and then create an echo file, and then use those two files, the original and the echo file, put it into EMU and analyze it. So let's first take Audacity, double click on that, it'll come up here, and now we want to open a file. The best thing to do is to import a file, not just open. Okay, import a file and use raw data, because we will be dealing with either PCM files, which are 16-bit linear, or ALAW files, or MULAW files. So in this case, I'm going to use an intrusive 16-bit linear file recorded at 8,000 samples per second, which is called intrusive FEM2. 20 stands for 20 seconds long. Open that file, and you have to tell Audacity what it is. It's a signed 16-bit PCM file, little endian, single channel, but it's 8,000 samples per second. 1, 2, 3, 8,000, and there it is. Now, this is the file that we are going to now add about 200 milliseconds of delay and attenuate it, and then use this as the echo file, because the original file is already exists. So we will modify this, attenuate it, delay it, and save it as with a different name. All right, so let's first introduce delay. So generate silence. Let's make it 200 milliseconds. Okay, so that is 0.2 seconds, which is equivalent to 200 milliseconds. And normally it'll put that right at the beginning. Now you see that it now has 200 milliseconds right smack at the beginning. So this file, we're going to now attenuate this file, because the EMU likes to analyze original and the echo or the delay file whenever they are whenever the delay echo file is lower, 6 dB or lower, because otherwise it thinks that the echo delay is really double talk. In other words, another person talking rather than the echo. What do we effect, right? Amplify. We're going to reduce this by -10. And so now I've got it at -10 dB, and I'm going to say OK to that. And as you can see, now the entire file is reduced by 10 dB. So we're going to use this file and save it. Okay, we just recently created a duplicate file, except that it has this front-end delay here, and we also attenuated it by 10 dB because the EMU program relies on the echo file being somewhat less than the original file. So we've satisfied that requirement. Now we need to save this before we use EMU. For that, we do this file, export audio, and here we want to just put we go to options, and we want to say signed 16 bits PCM, because these are all linear PCM files, raw headerless. Say OK, and then go here and just put .pcm and say save, and say OK to that. So now we have the two files available. Let's go get those files and bring up EMU and actually use it. Okay, I want to close this now. Okay, so now we have a file, or an original file and an echo file, and we want to use EMU to measure the delay of the echo and also the level of the echo. Double click on that. Okay, so it's up. And so now the echo measurement utility looks like this. It has two files that it wants to see. This is the intrusive signal file, meaning the file that does not have the echo. And this is the file that has the echo, or the delay, whatever you want to call it. And so we just, and then the rest of this is some analysis that happens after you've selected these two files and hit run. So let's first select the first file, I'm going to use the intrusive fem220.pcm file. That file is a 16-bit linear file, 8,000 samples per second, and I'm going to pick that 20 seconds long. Open that, and now you see it says 20 seconds, the intrusive signal file length, and pick the other one, which is that one. Open that. So now I've got the two files. The echo file is here. The original file is here. Both of them are about 20 seconds long. That makes sense. The original is about minus 13 dBm in total power, averaged, and then the echo signal is minus 24. Remember, we said we introduced 10 dB of loss. Okay, now we just run it. It should always be in frequency domain. This thing should be set to echo, and just say run. And within a short time, it will have processed this, and this is what you see. Let's take a look. Let's first expand this just a little bit so we see all the measurements. Now here we can see the way to read this. Remember, it was a 20-second file. The way the EMU works is it breaks everything up into 10-second blocks at the most, and or it'll look for single talker spurts. So in this case, it found, since everything was about 10 dB down, it did not see any double talk, so it broke it up into 10-second chunks. The first 10 seconds sees 4 echoes, but the strongest echo is minus 10. This is minus 42, minus 42, minus 45. Minus 10 is the strongest. The delay associated with that minus 10 dB echo is 200 milliseconds. So these 4 numbers correspond to these 4 numbers. And then in the second segment, the second 10 seconds, we also have 4 echoes identified. The strongest one is at minus 11, and that also happens to be at 200 milliseconds location. So the main echoes are at 200 milliseconds, and that makes sense. Let's just take a look at the main one. Put that down. These are the results that come up, and I think I explained this. So we want to apply this to the main GUI, and we see here that the echo is at about 200 milliseconds. And you can do things like this, if you like, to magnify it so that you can see it a little bit better. So now you can see that this echo is at exactly 200 milliseconds. And here are the values for that segment. The strongest echo is at minus 10 dB. This is a 10 dB attenuation there. And it's at 200 milliseconds. So we accomplished our objective. We had taken a file, created another file with an echo at 200 milliseconds of delay, front-end delay, which means that everything gets slid by 200 milliseconds. So there must have been a strong echo at 200 milliseconds. We further attenuated by 10 dB, and exactly that's what the ERL says. It's about 10 dB down. So this is how the EMU works. Now, another thing that we can do is we showed this for PCM, 16-bit linear. You can also do it for A-law or mu-law. One important thing is that the settings here be 8,000 samples per second, unless you're actually dealing with a 16,000 sample file. And the double talk detector should be set to about -6. Those are important settings. Otherwise, most of the rest of these is not that relevant. All right, if I go to detailed analysis for that particular segment, it'll show you that entire segment. You can play that segment. You can play the intrusive signal. You can play the echo signal. And you can see the error signal. And it shows that there was an impulse at 200 milliseconds. So these are for more a detailed analysis of the echo, and you can use it. You can play the file. That's the original file. That's the echo file, and you can do all those kinds of things. There's lots of other features in the EMU that you can use. Please read the manual for all of those things. Okay, thank you.